This lesson is over solving 1 and 2-step equations. Before we get into all the steps we need to solve it, let's look at our different parts of our equation. So our x, or any letter, is our variable term. So our variable is just a placeholder for another number or an unknown number. Then in front of it is called our coefficient. So our number with our variable is our coefficient. Then we have our variable. And then if we're adding anything to it and it doesn't have a variable term, it is our constant, because a 4 is always a 4 there. So we have our coefficient, which in this case is 15. Our variable in this example is x, and then our constant 4. So whenever we go to solve 1-step equations, we are going to isolate the variable. So that means we want to get the variable all by itself, and we're going to do so by using the inverse or the opposite operations. So we're going to use the inverse operations today to isolate our variable. On 2-step equations, we're going to solve this using 2 different steps. Our first is we're going to use addition and subtraction to remove the constant. Then next, we're going to use multiplication and division to remove the coefficient. And if for some reason we have to divide by a fraction, we're going to multiply by the reciprocal. Here we have a model of our solving equations. First, let's write this equation. Here I see 2 bars labeled x, so I see 2 x's, so I have 2x, and then I have an equal sign, and then I see negative 1s, and I see 1, 2, 3, 4, 5, 6 of them, so I have 2x equals negative 6. Here's a 1-step equation. I just have a coefficient, so I'm going to divide by that coefficient. Because 2 and x are being multiplied, I'm going to divide, which is the opposite or inverse operation. So I have x divided by 2 on one side, and then what I do to one side of the equal sign, I'm also going to do to the other. So then I have negative 6 divided by 2, which gives me x equals negative 3. All right, and then I'm always going to go through and I'm going to check my equation by plugging in what we think our variable term, where our variable is. And then if we did this right, this side of the equal sign will equal this side of the equal sign. So we're going to solve this out. 2 times negative 3 is negative 6. And so here I have negative 6 equals negative 6, and that is a true statement. So I know I did this correctly. Let's look at another example. Let's look at this first example. Here we just have 1-step equation, and we're going to do the inverse operation. So our inverse operation here is multiplication, because 1.5 is being multiplied. We're going to multiply 1.5 because we're dividing by 1.5. And so those two are inverse operations. So these will cancel out and make 1. So we have 1x equals, now I'm doing 16 times 1.5, which gets me 24. Then I'm just going to do my little check. I have 24 divided by 1.5 equals 16. So I'm just checking to see if this side is equal to this side, because our equations are a balanced scale. All right. So we want them equal to each other. So I'm going to do 24 divided by 1.5. If I have 1.5, I move my decimal point over. And there's my new decimal point. 15 can't go into 2. 15 goes into 24 one time. 1 times 15 is 15. I'm left with 9. I bring down my next number from that next place value, and 15 can go into 90 6 times. 6 times 15 is 90. So I have 16 equals 16 in my check, and I know I did it right. So these here are 1-step equations. Let's look at 2-step equations. So number 6, we have 14 plus 9m equals negative 13. Our first step is to get our constant over, because we want to isolate the variable, so we're going to move this constant over by subtracting. So our first step in solving is addition and subtraction to get all of our constants over. So I'm going to subtract 14. Positive 14 minus 14 is 0, so I zeroed them out. The inverse operation of adding 14 is subtracting, so I subtracted from both sides. I didn't do anything to 9m, so it just goes below, equals, and then I have negative 13 minus 14. This can also be written as negative 13 plus negative 14, because I'm really adding these two negative numbers and keeping that sign. I have negative 27. So now 9 and m are multiplying, equals negative 27. I'm going to divide by 9. Divide by 9. So I have m equals negative 27 divided by 9 is a negative 3. All right, I'm going to come over here and make sure I did this correctly by plugging negative 3 in for wherever I see m. So we have 14 plus 9 times negative 3 equals negative 13. So I do my parentheses first in solving PEMDAS. 9 times negative 3 is negative 27 plus 14. This can be rewritten as negative 27 plus 14 equals negative 13. So I'm going to be subtracting here because I have two different signs. And so we have negative 27 plus 14 gets me a negative 13, or a negative 13 equals a negative 13. So I know I did my steps correct whenever I go back through and plug it in. Another way we can solve this, if I'm confused on my first step, is to box and circle. So I'm going to box my term with the variable, and I'm going to circle my constant terms. Or right now I'm doing is identifying my like terms. Negative 12 and negative 6 are like terms because they both can be combined and don't have a variable with them. And so now I want to either add or subtract 6 to both sides, so that way I am getting my boxes on one side and circles on the other. So to zero out negative 6, I would add 6. And because I want my equation balanced, what I do to one side, I do to the other. So negative 12 plus 6 is negative 6 equals n divided by 2. And then that zeroes out over there, so I'm left with n divided by 2 equals negative 6. Now I have one box and one circle. So I'm now going to take my box and figure out how I can get rid of the dividing by 2. So if n is dividing by 2, I'm going to multiply by 2. And what I do to one side of my equation, I do to the other to keep it equal and balanced. So whenever we're dividing by 2, if we multiply it, we get 1. So we have 1n over here equals 2 times negative 6 is negative 12. Now I'm going to go through and check my work really quickly. Wherever I see n, I'm putting negative 12. So I have negative 12 divided by 2 minus 6 equals negative 12. Negative 12 divided by 2 is negative 6. Minus 6 equals negative 12. This can be written as negative 6 plus negative 6, which is negative 12, equals negative 12. That is a true statement. So I know for sure that n equals negative 12.